What's up everybody, welcome to this video. In this video we will make some exercises on VHDL, especially like the data flow style combinational design. We will do this gray code encoder. So this is obviously VHDL, it is a hardware description language. Most engineers, I think, have this, or they have Verilog. Verilog is a bit different, but so in my case, I have VHDL, and I mean this video can be useful for people that have to go through this pain and suffering. So let's do this together. Okay, so this is the exercise that I'm going to make and hopefully get right, and hopefully you can learn something out of it. Okay. So we have design a generic binary code gray code encoder. Both codes for generic and for are listed below. So for those who don't know what a gray encoder is basically binary code that gets transformed to gray code, and how the transformation works is simple. For example, this one here, 1001 becomes 1101. So obviously, if you look at the most significant bit or the most left bit, the obviously it's always the same. It just gets taken and bang, bang. So it just gets yeeted over to gray code, and then it goes from left to right or right to left. It doesn't matter, but mostly left to right. And then you just look at so if the first and the second are different bits, so 1 0 or 0 1, then it gives 1, you know. And then it goes further. 0 0 is obviously the same, so it gives 0, and then 0 1 is obviously the same, so it gives 1, you know. And now we shall try to write that shit VHDL. Okay, so I have this. It's just on Sublime Text. You can use any like coding shit. You can use Visual Studio, but my exam will be on paper, so it's simpler to use something that doesn't have too much help. So I've already used the libraries and shit. So yeah. Entity gray encoder, obviously you give it entity always, and then we have to obviously give it some ports. What the fuck? Okay, some ports. So port up. So what were the ports? Obviously we don't have too many ports in this bitch, so it's just binary. We'll give it bin, which is obviously the input of this exercise is of the std logic vector, and it is how many? It's 3 down to 0. Yeah. And then we have our gray output, which is also an std logic vector, 3 down to 0. Very simple, obviously. And that's about it. That's everything about our ports. And then we will obviously end it, and gray encounter, just like that. The colors match, so it's good. And then we have our architecture. And this is where we actually like write the what we will become for inputs, outputs, and so yeah. So let's think about this. So we already know that the most left bit is practically being kidnapped to the other side, though we can already write that. So, so we can write that our output gray, the most left, which is 0 1 2 3, so that's 3, gets the gets assigned binary 3. Simple as that. But then we have to think about, so we obviously start reading from the left to the right. We see, oh, this and this is the different, so we have one. So we obviously need to use a for loop. Yeah. So for I in 3 down to 0 loop. I hate this shit, man. I hate when they write it for me. So let's think about this. So gray, our gray I, you know, gets assigned the value binary I XOR binary I minus 1. If you're confused, what this basically is obviously, so wait, so it goes through it, and if, so gray gets assigned the value I, which goes from left to right, from 3 to 1, it gets binary I XOR binary I minus 1, so if it gets 1 and 1, it will obviously give 0. If it has 1 and 0, it will give 1. And you know how an XOR works. Let me look it up for you guys. An XOR, these are XORs, is basically what a gray counter is. So if you have two zeros, in this case it's 0, 1, 0, or it becomes 1, 1, 0, So that's why we use an XOR for this. And obviously that was about it. Then we obviously end our loop and generate and then our end arch. And that's about it. It's short, it's easy. The hard thing with these kind of exercises, obviously, just the thinking method. And if you didn't see the XOR, you are pretty screwed. But yeah. We will do another exercise after this break.